Hello.
Hello.
Okay. So, everyone can sit down or walk or stand awkwardly, that's fine. Wait, we need to focus the clicker, otherwise nothing works, and turn it on. Brilliant. So every relationship starts somewhere, you know. First, you're on your own, and then you meet some nice guy or some nice girl, and everything is new, everything is fresh. There's the butterflies, and you go out, and you start to get to know each other. And then her evil twin sister comes along, and then your mother tries to take over the family business. Okay, maybe I've been watching Jane the Virgin too much. Anyhow, we're here to talk about state.
And animation.
Okay.
So who are we? First of all, I'm Gil Fink, as Sebastian said. I'm a senior consultant. I'm a Microsoft MVP in the last 9 years. I'm an author. If you read the Pro Single-Page Application Development book, it's me. Okay? And I'm also the CEO of Sparksys. This is my own company, consulting company.
And I'm Opher. I'm a designer. I'm a musician. Sometimes I'm a gamer. And because JavaScript is good for all of these things, I became a developer. In my day-to-day, I'm a creative developer at a company called Echo. And I'm not sure how ecological we are, but I'm going to look into that. So, what exactly is animation? So, this is from a game called Cuphead. Does anyone know this game? Yeah, that's pretty cool. It's entirely made with classical animation, so drawn by hand. And I want you to look at the little birds, the yellow birds with the nail on their head. You're watching animation, in your mind, that seems like something that's moving, but it's not. It's a series of frames over time. These are separate frames that move in a rapid succession, and your brain translates this into something that's moving, that's alive. So if you look at this mathematically, that's actually a function that takes time as an input and outputs which frame to show. And why do we even need animation? Why should we do this?
So because
Oh.
animation is fun. Yeah, it's really fun.
Yeah, it is. But there are better, or not better, but there are other reasons to do animation. And we had a little spoiler here. But maybe one of the better reasons is that animation is a tool to convey information. And what type of information am I talking about? Okay, so there are several types. One of them is the sense of place. So where am I in the app? Let's see an example of that. So you have a card or an icon in a mobile app. And once you click that card, you can see where it goes, or what is its context inside the app. So that is a sense of place. And what about sense of action? So what exactly just happened? That is something that animation can also convey. So take an email client, for example. You open the email client, you open up a message, you start to type something, and then there are several options. The first option is that you actually send the message. So you send the message, and the window goes away. It zooms upwards. But you might also want to discard the message. Maybe what you wrote wasn't such a good idea, and you want to get rid of it. So animation can be a tool to differentiate between these two different actions. And what if you wanted to save this draft for later? So the exact same thing, closing the window, can now show you where exactly is this message going. So in this example, the window minimizes to the drafts icon, so now the user can tell where exactly the animation is, where exactly the message is. Okay. Animation can also convey the sense of state. So what type of behavior should a user expect. So for example, if your app does something asynchronously and loads data, an animation can convey that, okay, we don't have the data right now, but hang on tight. We're bringing that feed so you can scroll as much as you want. But hang on, it's not there yet. So we talked about state, and we talked about place, and we talked about action. These are the things that animation can convey.
So what's state? Okay, because we're talking about state and animation. So definition, it's the current snapshot of the application data. And when you start working with state is very hard. So if I start with one component in my application, then I have the component state. Some actions can affect that state, and then I update my view. So it's easy peasy. But what goes on when state goes wrong? What's happening? State can go wrong, okay? So for example, I have one component that have state, but it relates to another component with another state, and they share the same state as well. And maybe other components can have states which they are shared between other components. This is called the component party. So this is why we invented unidirectional data flow, and everybody is telling you to go and do only one direction of binding, not two-way binding, but rather one-way binding. So the look of the components and the application look like this. We have a view that sends an action, and we have some store. But we love to complicate things a lot. And this is why we invented design patterns like flux and redux. While they look very, very, very simple at first, they are not. They are complicated. And then we have the problem of what to do next. Should we implement the wheel? No, we don't have to implement the wheel because there are libraries that does that for us. We have Mobix and Flux and Redux, and those libraries are very cool. And they help us to save our state and to do things with state. So we can relax a little bit. And then I can tell you just one thing. When we are talking about state, it all comes down to one thing. State is just a function between the old state and an action that results in new state instantly. But animation also can relate to state. Nope. Of course. So let's do trivial. I state the obvious, but this is a list. Okay? And we want to make that list with animation of fly in and fly out. So if we take a look at the Angular or Angular animation, then you will have a trigger that writes some state, the in state, and then we have transition. What happens when you go from one state to another state? That's a state machine. And that state machine can look like this. This is a very schematic way of describing the previous animation, okay? We have non-list or void, and we move to in, or void to anything. And then we can go from anything to void, and then we get the animation of fly in and fly out. And we get some solution like this, okay? This is a more sophisticated animation. But animation not always is so trivial like the previous example.
So we just saw a simple example of a list animation where you have elements that are added to the list, they animate in, and elements that go out of the list, they animate out. But sometimes animations are more complex. They have more moving pieces. These pieces are tied together to each other. Let's take a look at an example of one of these. So this nice little thing is a multi-select box thingy. And you can see that when you select one item from the list, a lot of different things happen. I mean, it all looks nice and cool, but let's dive deeper exactly into how this animation looks like, its anatomy, if you will. So to start, a user clicks on an option. You have like the option in the list, and a user clicks on it. Immediately, what happens is this. The new option gets added to the state, and the screen flickers. This happens instantly because, again, state does not account for time. Can we hope? OK. Then the option disappear animation happens. And exactly following that, you have the squash animation happening concurrently with the rectangle appear animation. So that's the that thing being squashed and the rectangle appearing. So there's like an orchestration of different elements doing different things here. OK. Lastly, the small sketch label, that one gets expanded. So you have like a series of things that happen over time, and they're kind of correlated in some way with one another. So,
and then comes the QA, and they are starting to clicking on every element in our list, yeah?
Yeah.
Because we are users and we are insane, and we want to click on everything because we have sophisticated animation. What's going to happen here?
Yeah. So I went ahead and like designed this little thing, and it works perfectly. And then now what? So let's take that apart. So first, your user clicks on the option. And like I said, the option gets added to the state because that happens instantly. And then the animation starts happening. Like, animation takes time. And while that animation happens, the user clicks on the second option. And then the second option gets added to the state because, again, that happens instantly. Now what?
What is going to happen? You know what's going to happen. You will scratch your head and you'll say something like, I have a problem. I have a problem, and this is the real problem with animation. Animation is a function of time. It occurs over time. And on the other hand, state changes are instantly. We have a function that goes instantly. And they don't cooperate together very well. This is a problem. So what can we do with that?
So the German philosopher Martin Heidegger says this: temporality temporalizes in the future, which makes present in the process of having been. Or, and let that sink in, right? But my wife puts it better. She says, why aren't you here yet? And if we're on that topic, let's try to figure this out. How can we understand these things? There's a concept called animation timelines, which is kind of a data structure that tells us how actions that take time relate to each other, and how can we program them logically to try and understand how to make them do what we want them to do. And I want to explain this in a way that's like not so high level. So let's do story time. A couple of days ago, I was in my home, sitting on the couch, watching TV, like doing nothing. And I don't know like how it's like in your home, but in my home, doing nothing on the couch and watching TV is forbidden. And my wife saw that. So naturally, she kindly asked me to go and not do nothing, but to go and clean out the bathroom. Perfect. OK, so I went and started doing that. But unbeknownst to me, I must have left the living room in a sort of a state of disarray. So while cleaning the bathroom, she asked me again to clean out the living room. And at that point, I had a couple of options. So let's review these options. So the first one is where I go to the bathroom and start cleaning it. And then my wife asks me to clean the living room, so I can stop immediately and go and clean the living room. But the bathroom is clean to me, or not clean, which means that when my wife is going to get there,
you're going to be murdered.
Yeah, something like that. And if we take that back into animations, that solution is called skipping, which means that one animation starts. During that animation, you get an action, and then you immediately skip to the next animation, not continuing with the first one. So this solution isn't perfect, because no solution ever is. The upside for this solution is that the animation is always true relative to the state. Because the state changes instantly, and the animation changed instantly because you skipped it, then you get the user sees the true state as it is. But again, the downside of this is that this jumping between different animation is kind of a jerky.
Jerky turkey.
Okay, so this is one solution. The other solution is this. Again, I go out and clean the bathroom. And while cleaning the bathroom, I get this interrupt or request to go and clean the living room. But this time I wait, I clean the entire bathroom, and then I go and clean up the living room. The problem is this. After 5 hours, I come back to the bedroom, and we're not going to watch that show that she wanted to watch, which again, does not make her super happy.
Yeah, we can't make them all super happy.
This solution is called queuing, which means that one animation starts, you get the action during that animation, and then instead of jumping to the other animation, you just queue it and continue on from there. And like I said, no solution is perfect. So the obvious upside to this solution is that there's a fluidity in the animations. So they always flow from one to another, and you don't see any weird or quickie movement. But the downside of this is that you don't immediately see the state that currently is in the application, or anything. Oh, okay. The animations play catch up to the state. So if your user clicks a lot of things, and the state constantly changes, then the animations will take time until they reach the point where they reflect the current state. So these are two options. These are two ways of tackling this. But there is a third. You see, because the problem is that I can't clean both rooms at the same time. So obviously, the third solution is that I clean both rooms at the same time. And this goes like this. So I clean the bathroom, then I go back in time, and then I clean the living room at the exact same moment, and then I just finish.
I need such a thing in my house as well, so bring me those solutions.
Yeah, but you know, it's a problem. Like the offer from this timeline can't meet the offer from the previous timeline. Like they can't touch each other.
Yeah.
Anyhow, that kind of breaks my metaphor. When we go back to animation land, we'll try to figure this out. This is called additive animation. It means that you have one animation, and then you get an action, and then the second, as you get the action, the second animation also starts running concurrently. So if you have a rectangle on the bottom left, and it wants to animate right, and you get an action that tells it to animate to top, okay, then doing that and then both at the same time will make the rectangle move to top right. Let's see an example of this in action. So this is the rectangle moving with skipping, so skipping from one animation to another. And then when you do additive animation, everything flows much more smoothly. Okay? So this is solution 3, but the problem, even though it looks perfect and solves the problem completely, is that it doesn't solve the problem completely, because it works well for single elements and moving, animating position. It doesn't work for cases where you have lots of elements animating different properties at the same time. It just works for simpler types of animation. So we saw 2.5 solutions. The first one was skipping. The second one was queuing. And a half solution for specific cases, which is additive animation.
So which one are we supposed to pick? You know, you offer us solutions. Offer.
See what you did there.
Yeah.
That's a good question, but like any answer in our field of software, it depends, because it all depends on what exactly you want to achieve. That is, it's all about managing expectations. If it's more important to deliver at this current point in time a fluid experience to your users, then queuing might be the good route. But if conveying the exact state that the app is in is more important because it's time critical or something, then skipping is the way to go.
So this is where we are starting to go to Angular, because it's an Angular conference, yes? And we try to create some implementation using timelines. And the best way to go with that is going with GreenSock. GreenSock is a library, a very known library. It has an element called timelines, which you can use in order to manage your timelines of animations. And if you have some components that need to correlate their animation and everything else, then you'll probably want to use GreenSock to do that and not use the Angular animation, for example, or animation at all, because you want those to be synchronized. So let's take a look at the demo. So here we are with the application, the multi-select component, and you can see that everything works smooth, even though I clicked the thing here. This is the solution for queuing, okay? So we are queuing the animation, and it works, and etc. How we implement that? So first of all, we took GreenSock and brought it to our application, pm install GreenSock. Then we created a wrapper service on timeline. Timeline is a feature of GreenSock, okay? And we wrap that in a service, and in the constructor we create our timeline manager, which is going to manage all the timeline aspects of the application, or for this solution only for the multi-select. And we have a function here to add thing to our multi-select. The HTML for the multi-select, or the template for the multi-select, looks like this. We have multi-select item here, and multi-select selected item. I know the naming, not so good. But multi-select selected item is the selected item list, and the multi-select item is the list from which we are selecting elements. And you can see here the ng4 directive. So let's take a look at the multi-select item, okay? This is the multi-select item, the multi-select item, yes. And we have here a few things. Once you click on the item, then a select here is going to be fired, and we are going to create, using this get selected option timeline, a new timeline, which we are going to add to the major timeline, or the main timeline, okay, here at the end. And this will help us to create the first animation, which is the squat animation, the element that disappears. Then when the animation here finishes, okay, there is a callback, which is to emit an event to our multi-select component, which is going to answer to that by just pushing the item that was selected to the selected item array inside of it. And then we add another animation here. The animation here is going to be the removal of the item from the first array, okay? At the same time, when we added the selected item, what's going to happen is the multi-select selected item will be added to the DOM. And once it is added to the DOM with ng after view init, if you've been to Kim session, you heard about this and the life cycle of the component, then we create another timeline which we add to the main timeline, and then we can manage all the timelines in one place, okay? We're building on the injection of the same timeline in our application. As I said, the solution here is it's not trivial, but it has a lot of caveats. For example, one caveat here that you might not notice is we need to notify that the item was removed from the arrays. So we use the onDestroy event in order to do that. But, and here's the big but, once you have an event emitter, okay, in your application or in your component, then the event emitter is disposed before the ng on destroy happens. Okay, this is feature of Angular. So we had to do something like a small hack here, and we are wiring the subscribe for the items for each and every item that we have. Okay, and we emit the event, and then we call the complete in order to release the observable. Okay, so there are a few caveats that you can look at the example later on, and the example is online. Okay, so please go to this link, bit.ly and tutozop3. Okay, and you can download that demo and play with it a little bit, and hopefully you will learn how we created that animation. Okay, and then go and create your own implementation, your own queuing mechanism. So let's wrap up the session. We showed you a problem which is very, very non-trivial. We have on one side animation, which is a function of time. On the other side, we have the state, which is happening instantly. We move from the old state to a new state very, very fast, okay? And they don't correlate.
And we showed you 3 conceptual solutions. One is cutting and skipping from one animation to another. The other is queuing animation. And the third is additive animation, if possible.
So every relationship starts somewhere.
But the trick is that you have to manage expectations for it to work. That applies to Angular as well.
As relationships.
So
thank you very
so
much.